Alright, so it's been a minute since I've done a video, but I have good news and bad news. But in the meantime, I'll just get on with the bad news. The bad news is I'm still waiting for these parts, um, these frame rails, these mandrel bend frame rails. So for some context, I got a quote for the rails. I said this is great. There was a little hiccup because I didn't have enough clamping area on one spot, and they need to cut it into two pieces and weld it, or do it in two pieces and weld it together. I said that's fine. Um, They never got back to me. In the meantime, I went on vacation for 2 weeks. I came back, emailed them, nothing. Waited a week, emailed them again, nothing. So I have a plan B for that. That's the good news. So there's gonna be more progress soon, and other cool stuff that I just started doing. So uh, the project is still ongoing. I'm still working on it all the time. But in the meantime, well, it's kind of like a little lull in progress here. I wanted to do a video about another project I've been working on, which is really how I got started. Um, in thinking I could design a car and do this project, which is cheap go-karts, cheap electric go-karts. So I'm going to talk about that project today. I've done a lot of iterations, so the video might be a little long, and I'm sorry if it's a little boring. I'm just here in my office today, but I think you'll like it. So I think, you don't really have to explain why you want a go-kart or want to build one. They're just fun. Um, but a lot of them are just too much money for what they are. The problem with go-karts is there's not a lot of good places to use them for the average person. And a lot of people who live in apartments say like can't use them at all. Not just because of what they are, because they're too big or they have a gas-powered engine, which you really want a garage or an outside space to store it. So I kind of challenged myself to design a go-kart that was cheap and electric, so you could store it inside an apartment, uh, and very user-friendly, easy to put together, all that kind of stuff. And that process started for me a long time ago. It's actually one of the first projects with electronics I did. So I did 4 iterations. I actually just finished the last one. Iteration, kind of like 4.5 or 4.5, is just kind of perfecting 4. And hopefully I'm going to get to work on it soon. Senson is sponsoring the project again. So again, I'm kind of on their dole. They've been very good to me. So I'm going to talk about all the iterations, and I'm going to talk about the final one, other possible ways to go on this, my thoughts behind why I went the way I did, all kinds of stuff like that. So I'll start with the first iteration. Okay, so I have a list in front of me right here, so I don't get too off track as usual. But so I started designing and building my first electric go-kart around August of 2022. So I was still working for the drive at that point. I pitched it as a story. I forget if they paid, if I expensed it. I don't think I did, at least the first one. And I knew absolutely nothing about electricity effectively, or electronics. Electricity, I don't know. You know something about electricity, right? Going to school, but so I'd never worked with or purchased any lithium-ion batteries at all. I'd never used a motor controller. I didn't know what I was looking for. I had barely soldered before, so I soldered a little bit in college, but not electrical soldering really. I just kind of avoided it. Uh, I'd never designed a go-kart. I had booger welded some together before or something, just very ad hoc, but never designed one like in CAD or anything like that. And yeah, I was about as inexperienced as you could get doing this kind of thing. So I knew CAD, which is obviously a huge advantage in that situation, but in terms of go-kart design, there are much better go-kart designers than me who never learned CAD or anything like that. So yeah, it was a huge learning curve to start, but pretty quickly I narrowed down on what the design had to be cheap and easy to put together and all kinds of stuff like that. And that's what led me to my first iteration. So I kind of struggled internally with this for a while, but the first thing you have to do if you want to make a really cheap go-kart is you have to throw the fourth wheel out the window. Um, Four-wheel go-karts are really fun and the more like cars. There's ways to make them cool and refined. I've built some four-wheeled go-karts. If you want to make a cheap go-kart that's easy to put together, easy to order, um, inexpensive, more so than a four-wheel go-kart, you have to delete that fourth wheel and go with a reverse-trike. If you do a regular trike, it's not really a go-kart anymore, it's a tricycle. If you do a reverse-trike, you get a steering wheel, you get pedals like a normal go-kart, all kinds of stuff like that. So the reverse-trike is really key. The really key part of it is that the spars and the rear axle. So the rear axle just has so many individual components. You need the axle itself. I actually made a whole list here. You need the axle itself, which has to be keyed, and you have to have a a sprocket or a pulley to put onto it. So it's two separate parts. You need bearing blocks to support the axle. It's another two. A chain or a belt, two frame rails to mount the bearings onto. You need keyed hubs, wheels. You need to be able to move the motor or the axle to tension the chain or belt, or add a tensioner, which is a bunch of other little parts, and many more like small grub screws, that kind of thing, which all that adds up, and you can't really get all that stuff from a single place. McMaster car comes pretty close, but the go-kart hubs are not available from them, and they're tough to fabricate. You have to buy them. So yeah, that all stuff all adds up, and the only other real way to do it is to use two hub motors, out of a hoverboard. The hoverboard ones are a little small, but they're single shaft, which you really want. But even then, it gets expensive because you need to buy two motors, you need to buy two inverters or two controllers in one case. It's a lot to wire. Wiring the throttle is annoying. Wiring the hall sensors is annoying. We'll explain what that is later. But it also kind of adds up into there's no great way to do an inexpensive four-wheeled go-kart like out of the box without doing some fabrication. And that was really unsatisfying to me. And I, not quickly, but I gradually came around to the idea that a reverse-trike would be better and cheaper. And that turned out to be true. So I documented all this while I was doing it. So let me talk about my first iteration. So the first iteration had a sheet metal front axle, which was combined with the foot plate, and which is actually I still think is a pretty interesting design. But the main spar was an extrusion. It wasn't a piece of sheet metal or a tube or anything like that. I wanted it to be strong and thin and cheap and easy to order, and you can order those extrusions cut to length. That seemed like a pretty good idea. It's easy to mount stuff to extrusions. So that seemed to make a lot of sense for me at the time. And obviously there's some cons. It's like you have to source the extrusions and the sheet metal separately. But at the time that seemed like a pretty reasonable compromise, which I eventually moved away from, but it did work. I started with, again, going back to, I didn't know what any of these motor controllers were. I ordered like a square wave fan controller on eBay, and that is just not really meant to be loaded like that or be start from low speeds. So our first design, so I put the fan controller on the cart, hooked it up to the hub motor, and it actually kind of worked. It didn't really work when it was like loaded with a person on it, but it would kind of cruise around by itself in my parking garage. So it kind of worked. But I realized that it would probably be best for me to move to a VESC-style controller after that, and that's what I did. So once I figured out the control and everything, it did work, but there was like a lot of issues with it that, how refined can you really make a go-kart? But they were just like things that I didn't like about it. So it was big, it was wide, didn't fit through a doorway, which is annoying when I tested it, because it kind of had to be struggled out my door and then on the elevator. And so I wanted to make it narrower. It was too long. It did fit in my elevator, but just kind of barely. So I wanted to make it shorter. It's a go-kart. The ergonomics are never going to be great. So I figured, well, we might as well make it shorter anyway. The foot plate front axle situation, I find it interesting now, but not so much at the time. I didn't think it was going to be rigid enough. I think it probably would be now if I designed it properly. But you have to have a lot of little parts to kind of make it work. You can see that in the design. So I didn't really like that. It also required a lot of hardware, that design, from different vendors. So there was like eye bolts going on to hold the brake cable and T-nuts to install stuff, and it was annoying to put together because of the T-nuts and all kinds of stuff like that. I used solid front wheels as well, which is just a bad idea. They wore out really quickly. They were from Harbor Freight. I rode like shit. I also never figured out a throttle pedal for that car. So I didn't know what ADC was at the time. ADC is a common, not protocol, but method for, it's like an e-bike throttle, 3 wires. It's like the way the e-bike throttle and the motor control communicate. I did not understand that at the time. So I never found a good throttle pedal. I ended up making my own for the next iteration. But yeah, I was just kind of cruising around with a knob on my lap, just kind of adjusting the throttle like that, which is obviously not ideal. But it did work, and it was really cool, really exciting to build something like that from scratch. So again, I'll post the original articles that I wrote at the time. But that was really, really cool. I was like, I had learned so much up to that point. I learned about batteries. That go-kart had a hoverboard battery, 36 volt, which I still use in karts today. It's like a lot of learning went on. and it really set the groundwork for like everything I'm doing now, including the car, which is pretty cool. So I'll start talking about the next iteration by talking about the things I liked about the first one that I got right. I liked at the time I liked that extruded spar. That just, it wasn't rigid enough, but you could get bigger ones and they weren't that much more money. And if I made it shorter, they would kind of offset the cost. So it's like, okay, for the next design, I'll go for a wider extruded aluminum spar because then the seat was still adjustable, all kinds of stuff like that. This is still a feature on my current karts, the threaded rod steering column. Some dude on Twitter was like, "Oh, you need to make the steering column like bigger so it like collapses." It's like, this is a go-kart. There are no safe go-karts. I just want to put that out there. There's no such thing as a safe go-kart. So if you want to get into an argument about how this go-kart's unsafe or it's not as stable because it's a reverse-trike, I'm not going to argue with you just because, even things like UTVs that have full cages are not safe. I used to work with a guy who got in a UTV accident, and they put those nets on the side because it's your instinct in one of those things to put your hand out to stop it if it's rolling over. And that's what happened to him, and his hand got seriously messed up. So even stuff like that with a full cage, they're not safe. None of these vehicles, like go-karts, are safe. So if anyone, if you're ever designing a go-kart and someone says, well, that doesn't look very safe, it's pretty okay to just ignore those people. But the threaded rod steering column, someone was like, oh, you're just going to get speared in the chest by that. It's like, yeah, I guess, man. But it's a really smart idea because patting myself on the back here, it locates the column laterally. I see a lot of go-karts and they have just a keyed shaft as a steering column, but you need to have little collars on there to locate it, and then mounting the steering column kind of gets difficult. You need another fabricated piece to mount the steering wheel. So with a threaded rod, it locates itself because it's threaded, and you can just I use screw mount nuts up until last generation. That would you get them on McMaster, that just bolt onto the cart, and then it just threads in, which is great. It goes together really easy. It's really solid. It's controlled laterally, and then the steering wheel, you just run two nuts against each other, and it stays on pretty much forever if you use serrated nuts, which I learned the hard way. So that was really cool. And the basic steering system I carried up right into the last generation where I improved it actually. And the 36-volt hoverboard battery. They're just great little batteries. You can get them pretty cheap. They're 10S 2P. Okay capacity. I think it's use 2,000 milliamp hour 18650s. So they're $40-$60. Pretty good cheap choice. You can use any batteries on these. You can use car batteries if you wanted to. But those were nice and compact and good for testing. And they have an XT60 on them, which is a popular go-kart kind of drone consumer electronics, hybrid electronic connector. Just right on there usually. So it makes them really easy to hook up. But yeah, so I carried all that stuff over into the second iteration. So that brings me to the second iteration of this thing. So a lot of improvements on the second iteration. As I said, a lot of stuff I carried through. So it got smaller, fit through a doorway. It got shorter. I think the spar was 32 inches. I don't remember. But got a lot shorter. Spar got thicker, so the whole thing was very stiff. It's still very stiff. I actually still have it. It's at my parents' place. It still works. I still use it. I switched to an extruded front spar. So I told you I didn't really like the combination footplate spar before. So the extruded spar, the cool thing about extrusions is that they have holes in them which you can tap. So I could just attach kind of upright kingpin mounting points to the end of the extrusion, which is still a pretty good design. But that allowed me also to go to a flat steel footplate, which is more comfortable, more practical, and that's just all this stuff attaches together with T-nuts. I also went to pneumatic front tires, which is just a huge improvement in comfort. Solid front tires are not the way to go. If you're going to build one of these, don't do that. They're really cheap from Harbor Freight. The pneumatic ones, $10 each or something, maybe even cheaper on sale. But they come in a bunch of colors too. Sorry, I'm getting off track here. But those attach really easily, and they're really good, and sometimes a little off balance, but it's okay. I also bushed the steering knuckles. So before, it was metal on metal contact. I just threw a bunch of grease in there. It actually works fine, but I was worried about it seizing up over time, and there's this gray paste forming in there. So I knew that the steering, wanted to be happier. So I 3D printed some bushings for the knuckles, and that worked very well. Again, it's still working. I tried a ton of experiments with it as well. So I put these LFP batteries called headways inside the extrusion because I wanted to use that space. but the voltage was too low, so I used a boost converter to get it up to like back to my regular battery voltage, which thinking back on, I really didn't have to do. But yeah, I made this big hot dog battery, put it in there. It actually worked very well. You couldn't do regen because it wasn't a bidirectional boost converter, but still really cool. And then eventually I took that battery out. I still have the cell somewhere, but I put a 2 kilowatt hour Audi module that I got from battery hookup, or it must have been from battery hookup. I got one of those, and that's the battery that's still on there, and that's a great battery for it. I like never have to charge the thing. It's 48 volts or 44 volts, so plenty fast, plenty of power. Takes a ton of regen, pretty cool. I added a bunch of instrumentation, so I added a voltmeter and an on-off switch. Then after that, I got a Bluetooth dongle for the Vest controller, and I put a Amazon Fire tablet on the cart, which charged from the battery. So I attached a buck converter to the battery so I could get 5 volts to that. And so I had this little display on it, like a gauge package, which is pretty cool. All that stuff is still on there, all still works. But yeah, I ended up releasing that design for the cart. Again, I wrote stories about it at the drive. So I guess I'll link it. I'm still working on another version of this card, obviously, I'm going to release. But so I think some people actually, very many people, I know of at least half a dozen that were built, which is pretty cool. But I felt like there were a lot of improvements to go on there. It could still be assembled by anyone, like with minimal tools. But the extrusions had to be ordered separately, required a lot of hardware. Here's a picture of everything it took to put into the car. I took several pictures of that. I actually made a pretty slick video of me putting it together as well. Yeah, the T-nuts still made it annoying to assemble. Aligning the T-nuts is just like kind of a nightmare, and they kind of embed themselves in the aluminum because they're made of like steel, zinc-coated steel, which if you misalign one once and you really tighten it down, it's like a nightmare because it wants to realign in that groove again. But again, it's just multiple part sources, separate shipping costs, all that stuff adds up, and there was 3D printed components in there still, which, if you don't have a 3D printer, it's like hard to source those parts. You have to just have someone else print them for you, which is not ideal. So all these things in mind led me to the third iteration, which is very, very similar to the latest one that I've worked on. And there's actually kind of two versions of it, but there was a long space of time between me doing that last go-kart and working on the third iteration. So it was about a year and a half, 2 years before I started doing the third iteration. But I still remember what I wanted to improve about it. So I wanted to get it cheaper. I wanted to make it much easier to assemble. I wanted to make the part sourcing easier. And I wanted to optimize the size. Second one was a little bit small. Just like the track was a little bit narrow. It's like, again, you begin to understand the compromises involved in something like this when I say that. Like, sure, it fit through a door now, but it wasn't as stable as I wanted it to be. And like, sure, it was shorter, but I felt like I could use a little bit of length. A lot of stuff like that. So all this added up to a couple of things that I thought I should do to address those problems. The first was all sheet metal construction. If you did that, you wouldn't have to go to a extrusion company to get the extrusion for the main spar, which would be big. The second is the addition of PEM nuts or PEM nuts, PEM hardware. They're basically nuts, studs, all kinds of stuff that get pressed into sheet metal. And a lot of companies do that now. So Oshkosh's coming out with it soon. Other companies are working on it. Senson has it and Fabworks have it. So the third iteration I ordered from Fabworks. And with those PEM nuts, I wanted to standardize as much of the bolt as possible. So I wanted to all be basically quarter 20 fasteners, ideally all the same length. And I wanted to remove the mechanical brake. Again, maybe like a controversial thing, but not really to me. The mechanical brake is a pain in the ass to hook up. It's a bunch of other parts to source. It's you can get really strong regen on such a light go-kart. You can put your feet down to stop the thing. Just not really an issue anymore. If you rode one of my go-karts with strong regen, you'd feel the same way. It's kind of a cool thing to have, but not necessary in the end. Again, there are no safe go-karts. But I want to get rid of the mechanical brake. And I started to do that first prototype. So I'll put some pictures up of it now. So the first one was just a U-channel because I wanted to keep it cheap. I wanted to make that like one part. And it just twisted around a ton. It was thin gauge because I wanted to make it cheap, and thinner gauges are cheaper, obviously. and it was just torsionally, it was laterally or longitudinally stiff enough to support my weight, but it was twisting around the whole front axle whenever I moved around. The front axle was stiff enough, which is good, which was a great first step, but main spar I had to change. So I ended up adding a stiffener. I drilled some holes in the spar I got, and I ordered another stiffening piece, and that kind of addressed it. The problem was that the seat mount was still flimsy, and the rear wheel attachment was pretty weak. So I got something together enough to test it, and I was driving around, and when I got it back in, the rear wheel was like cocked off to the side. So the wheel mount wasn't strong enough, wasn't stiff enough. And the front axle was too wide. So I kind of, I had clearly forgotten about all these ergonomic things I did in the second iteration, and added up to a bunch of little issues like that. And the hardware diversity was still high. So it was all quarter 20, almost entirely quarter 20 now. But different lengths, which I didn't like. Plus, the steering hadn't changed since the first one I did. So you had to buy 4 rod ends and threaded tie rods. So just like pieces of all thread basically. And this version, you had to cut them with a hacksaw to the right length. In the second version, you didn't have to do that. That actually sort of determined my front axle width. You can just buy the tie rods off McMaster. They're expensive. I didn't really like that. And it looked like shit. I mean, just like bare steel like that doesn't look great. I don't know. Maybe that's just me, but didn't like the way it looked. And so I decided to go for what I thought was going to be a 4th iteration. It was really like iteration 3.5. And that came from RMFG. But before I go into that, the positives, the PEM nuts made assembly much easier. The sheet metal spars were definitely possible. They needed to be optimized. I did a new taller knuckle design, which was stiffer for that one. It fit outside the front axle instead of inside of it, and that made it made the bushing size a lot more flexible. Increased the steering angle. So that was just a better design. And I finally found an electric throttle pedal that worked. So I figured out how to wire that up. So that was a good step. I'll just put up a picture now. Yes, I forgot to mention it before, but I made my own 3D printed throttle pedal for the second iteration. It's just a servo tester. Still works. It's still on there, but obviously not ideal for somebody to have to 3D print that whole thing. So finding an electric throttle pedal off the shelf that worked was a pretty big deal. So iteration 3.5 was kind of like not half cocked. So basically, I got to know Kenneth, who runs RMFG, who's one of the newer, probably the newest sheet metal manufacturing brake bending kind of companies. And I was like, I liked his service. It was really cheap. So I was like, hey, Kenneth, why don't we do a project together? I'll do this, in my mind, I was like, I'll get a new go-kart out of it. Kenneth will get a bunch of publicity. Kenneth had kids. He can, film his kids riding around the go-kart. It'll be great. So he's like, yeah, that's a good idea. I'll call with him and everything. And in the meantime, I got laid off my job. So obviously no story was going to come of this. And then I got the parts, and because of DFM issues at Fabworks, they have a different press brake than RMFG with different tooling. And the main channel they could do fine. RMFG had different tooling, and they just couldn't bend that main section. It's a tough part to bend. You need special gooseneck tooling for it, which RMFG had just started they didn't have. So it wasn't bent completely. They did the best they could. Some of the little issues too in terms of tolerance on my end. So I was like, it didn't really go together right, but I still learned a lot from it, which was having a main spar that's thinner material along the bottom with a thicker upper area that was also the rear wheel mount was probably the way to go. That part worked. I was able to get that together. I added a small stiffener plate to the seat mount. That worked, which was great. A lot of the reinforcement between the front spar and the main spar, the lengthways on the top of the T and the vertical part of the T, I figured out a lot of that reinforcement wasn't necessary. I had all kinds of through bolts and stuff going on there and different faster lengths, and I figured out that it just not needed. I could get rid of a lot of that stuff. And I figured out that a lot of the PEM nuts that I did in the first iteration 3 were not necessary. I had too many. I could get rid of some of them. So it saved me a lot of money. So RMFG didn't offer PEM nuts at the time. So that design actually was going together without any PEM nuts at all, which is pretty cool because if you had a press brake and a laser or whatever, like a plasma cutter, you could make this cart yourself. I think the PEM nuts are better, so I'm going to stick with that. But just as a note, it is definitely possible to do without the PEM nuts. And finally, that brings us to iteration 4, which is the one that is probably going to be the final iteration. There's not a ton left to optimize on it, this is all going to be very impressive, I'm sure, for you to hear this final design. So Senson obviously is sponsoring the car project, and I've gotten to know Jim really well and the whole team there, and they have this marketplace, and I was like, hey, it seems like there's not a lot of standalone products in your marketplace. There's a lot of like car parts and accessories, which are cool, but it's like if you want to buy something, like there's no cheese grater on Senson, to use a out of park example. It's like, hey, why don't I design this go-kart for your marketplace and we can put it on there? And this is still in progress, so Jim was like, yeah, sure. So I get in contact with some other people there, and I start designing this go-kart to work with Senson. And they have a lot of value-added services and a lot of materials. So they have PEM nuts and dimple dies, other PEM hardware, Delrin plastics, powder coating, if I didn't say that already, all kinds of stuff, which means you can make a really cool go-kart. And so yeah, I'll just show you that. That was the lead image of this video anyway. But yeah, even without paint, I think the dimple dies will look really cool. But obviously I just decided to go all in on their value-added services for this version. Yeah, let me talk about the positives, the improvements. There's just a lot of little improvements here and a lot of cool stuff going on. The first thing is that the kart looks great now. It looks better than it ever has, I think. Even without the paint, the dimple dies just look really cool. The other thing is that I've gotten rid of all the 3D printed parts. So there was a steering adapter still kicking around and some steering bushings that were still 3D printed. Those problems were solved separately. So the steering adapter was just eliminated. It's the steering wheel. It's the yoke now. It's just a piece of aluminum plate. So that massively simplifies that. And the steering bushings are now, because of that new knuckle design I did in the 3rd generation, those can be pretty much any thickness. So I just tailor them to be the right size for Senkon's Delrin, so that you get those bushings from Senson now too. The hardware has been massively standardized. So outside of the steering parts, which require a little bit of special stuff, you can put the whole thing together with 1-inch quarter 20 bolts, or 3/4, even 1/2. The seat just requires 3/4 or 1-inch to mount the seat, but really you could use almost entirely 1/2. So that's basically all the hardware. Besides the steering, there's no other hardware. The hardware to mount the motor comes with it, so it's about as simple as it gets. The steering, which requires special hardware, has also been simplified. So I used to use shoulder bolts. Those are expensive. I got rid of them. I use regular bolts now. It's kind of enabled by the Delrin. The steering used to be one pitman arm connected to 2 separate tie rods, which each of them 2 rod ends and a piece that threaded onto a piece of wall thread. So basically 2 separate linkages. That's been simplified. It's now one bent steel connection piece, kind of a parallel link, and that connects to only one sort of tie rod piece. I forget what it's called in proper automotive parlance, and that just hooks up to the pitman arm. So it's half the number of rod ends, and you don't have to cut the all thread anymore. You can just get a piece of 1-foot all thread from McMaster. So it's a lot easier, a lot simpler and cheaper. Also, the screw mount nuts for the steering column are now just pieces from Senson, so you don't have to buy that separately anymore. So it's just 2 little plates that get the right taps in them. They hook right up to the steering pieces. So all that stuff is just, makes sourcing easier, makes assembly easier. Really, really cool. This is just include all the PEM nuts too. So there are no, or very few, I think there's like 6 actual nuts on this cart. Almost all the nuts are integral to the design. So you don't have to buy a lot of nuts to get this project finished. I switched to, I designed it for is it Xiaomi M365 hub motor, which is really, really common. You can get it for like $50 or $60. They have different tires for them, different wattages, whatever you want, that'll hook right up to this thing. Still use the hoverboard battery. I think it'll support up to 36 or 48 volts, the motor or the controller, but this is just 36 volts, which is fine. I'm still using a VESC. Those parts have come down in price since I've started working on this project, which is cool. they fit inside the spar too now, which is nice. Um, I also added 5 degrees of caster to the front because why not? You can just do that. Adds a little bit of stability. I think it makes the car look a little cooler too. Also, I think the spar length is right about perfect. Maybe a little narrower on the front, but I think it's pretty good now. Um, and yeah, I might have said this before, but it's so much easier to assemble. There's like a couple of part design choices I made, which I'll talk about in a second. But yeah, it just goes together so easy now. I do want to stop before I talk about the negatives of this thing, which I'm going to address in like a Generation 4.5 as a final. I want to stop and talk about the main spar because it's probably the most impressive piece of sheet metal I've ever designed. Um, there's a lot going on here. So I mentioned before that RMFG, because it didn't have the right tooling, which a lot of people don't have, um, couldn't bend that deep channel for me. Actually, Senson has bending rules that they say they won't do a channel as deep as I did on this spar. And the reason is that the part collides with the press brake tooling if you make the channel too deep. Senkossen's rules are actually like a 2-to-1 ratio between the flat part of the U and the sides, for good reason. But you can cheat. Well, not really cheat, you just have to design creatively. You can do a very deep channel on a press brake if you do a V-shaped bottom face and you do it as the final operation. So that way, when you form this deep channel, you have 2 sort of gradual edges that you preformed, and the final 90-degree channel gets formed around that piece of tooling, not colliding with it. The problem is that you need a gauging surface to do that. And a gauging surface is basically just a surface that, say if you wanted to bend a piece of metal in half precisely, like hot dog style, and you want to get to the exact middle, CNC press brakes have a gauging block that will automatically go to the right distance, so you can press that piece of metal up against the gauging block. The tooling comes down and bends the piece perfectly in the middle. The problem is when you're trying to do one of those final V channels, you often have to get creative in the way you design your gauging surface. It's kind of difficult. But thanks to one of the Senson support people, I had an idea of how to do it, and he modified my idea to better suit their tooling. And yeah, just there's these 2 little features on there that look pretty cool now, and they allow for that final channel to be bent. And in combination with the dimple dies and the caster on the front axle, which is so that the front flange surfaces are angled, and the seat mount is angled too, just to give a little bit of clearance to the plastic seat I'm using. It looks cool though. And yeah, with the dimples and the yellow and everything and the cool features, just a really, really cool part. And it really shows how far you can go in sheet metal, and how sheet metal can actually be better than something like a tube if you know how to design it properly. And I'll go into that more later because that's something people have said is that should be a tube. It's actually better as sheet metal, and I'll talk about why in a little bit. But yeah, the negatives of this design are just kind of like processy things. So this car weighs too much, so it should be de-gauged, but I think it should really just be aluminum. Aluminum is about the same cost as steel from Senson. It'll be a lot lighter. It's just heavy. It's not really super heavy right now, but it's like a 10th inch steel all the way around. So it's I guess it's like brick shithouse tier, but it doesn't really bother me that much because it's really, really rigid, very stable. The other issues are really just like tolerance issues. Some of the bolt holes are really tight. Like it's just like you can't expect every service to make every single one of your parts exactly right every time. And but when I prototype, I do go in with that assumption, and because then I learn that this particular manufacturer's tolerance issues. And Senson is just like when you get to those kind of complex bends and they all kind of stack up, and with the caster on the front end and the way they connect. Bottom line, I just have to make some bolt holes a little bit bigger, and that should solve that problem. And so yeah, those are all pretty much the biggest problems I need to solve. Those are the only problems I need to solve now. And those are really actually already solved them. I'm just waiting on another code from Senson to order those parts. So yeah, when I get that one, I'll wire it up, and I'll probably do it bare aluminum. I think that'll look cool, and that'll be on Senson's marketplace. So that'll be pretty nice. So yeah, that's like the final iteration for now of this whole idea, I guess. But yeah, as you can tell, it's kind of been a long journey to get here. But yeah, I just want to kind of do like some notes like for future stuff. So yeah, I guess there is there's not really future versions that I have in mind, but there's cheaper versions, optimized versions. Maybe the dimple dies aren't necessary. Maybe I do a version without PEM nuts. Because again, if you already have fasteners, or maybe it's stable enough without the dimple dies or whatever, I want to be able to offer those kind of cheaper options for people. No powder coating, kind of stuff like that. Like a variety of price ranges to get it as cheap as I can. One of those iterations is doing it out of 2x4s, so that massively cuts down the price. You need small metal pieces that just do key things. I think if someone just wants a go-kart as cheap as possible, they can make one out of 2x4s. I think that's a really good solution. So I'm probably going to do a kit like that too. And yeah, I just want to talk about some side notes really quick, because a lot of people, as I've been doing this, have sort of said things to me that make sense on the face of them, but as I've gone through, don't make a lot of sense. Or they do, but if you want to optimize it, this design really for assembly and all these different kind of things that I do, they don't really add up in the end. One of them is that people say I should use tube instead of sheet metal to make this cart's chassis. It's kind of one of those things that makes a lot of sense on the face of it, but doesn't make a lot of sense because I've tried to do it. It doesn't make a lot of sense when you get through to doing it. The key trouble is the mounting of the rear wheel, the rear motor, and the attachment point between the front spar and the mid spar. You need to have some kind of bracket there if you're not welding it, which is unnecessary in this instance. Like, why would you weld a go-kart? It doesn't make any sense to me. Like, weld is not structurally necessary here. You end up needing like L brackets basically, and then those need either through bolts, which pinch the tube and don't offer clearance for the other bolt to have to go the other way, and you need different lengths of hardware, and you need to buy nuts, and you need to cut clearance holes, or you end up in this like kind of just compromisey place. And it can be done with sheet. So, and if it can be done with sheet, you should do it in sheet. You would end up kind of with this unsatisfying design where you can't implement as many features as you want into as many parts as you'd like. So it's like, the main spar for me forms the attachment point for the front spar, and it forms a seat mount, all kinds of stuff. It just does a lot of things. And when you go to tube, you kind of lose that functionality, because lasering tube is like a reductive process, like machining. It's not like forming plate or forming sheet where you can add features and it's not additive manufacturing, right? But it's like you're more flexible in what you can do with sheet if you know what you're doing. So that's one of the things that people have said to me, and I think there's probably a place for a tube cart. I think there's actually a lot of different ways you could go about it, but I think the sheet metal design is the best in the end. And speaking of sheet metal, I have an experimental design that's all one sheet, so the front spar and the mid spar are formed as one piece, which would be a lot cheaper. It looks like shit. It's pretty cool though, and I might do a test with that too. I'm not sure, but that just kind of eliminates a lot of components. I don't know if I'll end up doing that again. It's kind of like a weird design, but yeah, I hope you enjoyed me going through this. I shared a lot of pictures and videos and stuff that I hope you found interesting. So yeah, again, hopefully this will be on the Senson Content Marketplace soon. Very happy that they sponsored the project. I'm happy they're sponsoring all my stuff. A lot of this just would not be possible without them. Yeah, so again, sorry about no car update this time, but I'm as frustrated as you are. So as soon as I have an update on that and other little stuff I'm working on, I'll post another video, hopefully in about 2 weeks time here. So yeah, see you guys next time.